So today we are going to start with the chapter Algebra in Maths. So the first thing here we learn about is variables, and it means something that can vary or change, and its value is not fixed and it can have different values. So we directly start with the exercise of this chapter, where the first sum tells us that we need a variable to form the patterns that are given in each side. So the first sum says that we need to make a t with the matchstick. So the first variable that we take is let n be the variable. Therefore, to make the pattern of letter T, we write here is 2n. The reason being, 2 matchsticks are required and n is the variable, therefore it is 2n. So likewise for letter V, 2 matchsticks are required, so we are taking n as the variable, and to make the pattern of the letter V, we make it as 2n. And for Z, we take n be the variable, and to make the pattern Z, 3n. So 3 is here because 3 matchsticks and n being the variable. Same with the letter U. See, we have 3 matchsticks and n is the variable, so it is 3n. The second sum, if there are 24 mangoes in a box, how will you write the number of mangoes in terms of the number of boxes? Use B for the number of boxes. We are considering let B be the number of boxes. It was given, and number of mangoes in the box were 24. So therefore number of mangoes in terms of number of boxes will be 24b, being 24 is the number of mangoes and b is the number of boxes. Third sum, Anuradha is drawing a dot rangoli. She has 8 dots in a row. How many dots will her rangoli have for R rows? So now here there are 8 dots in a row. So dots in a row will be 8, and R is the number of rows, so it will be 8R. Now for the second part, how many dots are there if there are 12 rows? If number of rows is 12 and each row has 8, so it is 8 into 12, that is 96 dots. See here, dots in a row is 8, R is the number of rows, and dots in 8 row will be 8R. For the second part, dot in a row is 8 and dots in 12 rows will be 8 into 12, that is 96 dots. Fourth sum, Anu and Minu are sisters. Anu is 5 years younger than Minu. Then Minu is the elder sister. Can you write Anu's age in terms of Minu's age? Take Minu's age as x years. So if Minu is x and Anu is 5 years younger, that means she is smaller than Minu by 5 years. So it will be x minus 5. Minu's age is x years and Anu is 5 years younger than Minu. That is x minus 5 years. These oranges are to be transferred from larger boxes to smaller boxes. When a large box is emptied, oranges from it fill 3 smaller boxes, and still there are 7 oranges are left. If the number of oranges in a small box are taken to be x, then what is the number of oranges in the larger box? So here it is said that small box we have to take it as x, and there are 3 smaller boxes, so it will be 3x, and after recovering all there are 7 oranges left. So total number will be 3x plus 7 oranges. Number of oranges in small box is x. Number of oranges in 3 small box will be 3x. Number of oranges left will be 7. Therefore, total orange in larger box will be 3x plus 7. Harsha's score in mathematics is 15, more than 3/4 of her score in science. If she scores x marks in science, find her score in mathematics. So look at this now. Marks scored in science is x, and marks scored in maths will be, that is 3/4 of her marks in science plus 15 more that she got, that will be 3 by 4 into x, that is 3 by 4x plus 15 for the extra marks she got in maths with respect to the science. 7th sum, look at the following matchstick pattern of equilateral triangles. The triangles are not separate. Two neighboring triangles have common matchstick. Observe the pattern and find the rule that gives the number of matchsticks. Okay, here equilateral triangle means where all the sides of the triangles are equal. See, there are three equilateral triangles that are given. For the first one, there is one, and there are three matchsticks. And for the second one, there are two equilateral triangles with one base in common, and there are two matchsticks and one here, and there are two matchsticks and one here. So this matchstick is common to both the triangles. Same way for the third one, there are three equilateral triangles, and in this case we are going to consider these two at first. See, there are the two and the third is now looking quite the same, and they have one matchstick in common. And if we hide this triangle and consider these two triangles again, and we here also see one matchstick is common to both the triangles here. So in this sum we can conclude that there are two number of matchsticks that are left behind, so that is 2n, and one is the common one that comes in each case, so it is 2n plus 1. Same way, observe the following matchstick pattern of letters A. The A's are not separate. Two neighboring A's have two common matchsticks. Find the rule that gives the number of matchsticks. See, this is the A, and here there is one matchstick. Same way, there are two A's, and see, there are two matchsticks here and four, that these two matchsticks are common to both the A's, and rest four matchsticks are not common to the A's. Same way, there are three A's, and there are two matchsticks that are common in both. This one is common to these two A's, and this one is common to these two A's. So here we can write A as number as n, and as there are four matchsticks that are not common, so that is 4n, and that are common to all the A's that are two matchsticks. Over here also this is two matchstick in common. Over here also these two matchstick, and for these two A, these two matchsticks. So 4n plus 2.